Hello, this is Mr. Eric. I'm here to talk to you about lesson 4.6, the sixth lesson from chapter 4. This will be over isosceles and equilateral triangles. Now make sure there's some stuff to take down in the notes. Make sure you're keeping track of that. We'll do a note check at the end of chapter 4. Some things that we need to talk about. First off, isosceles triangles. There's some information there, some definitions, but it might help you to make a sketch somewhat like this. If we have an isosceles triangle, no matter which way it's going, it could be something that looks like this, but these two sides that are the equal sides are referred to as the legs of the isosceles triangle. It's a vocabulary word that seems simple, but you're going to have to look at it a lot. The angle up here that would be at the top or bridging the legs right here would be our vertex angle, and then the other two angles are called the base angles. Now the theorems, if you want to take them down word for word, they're on page 285, but 4.10 says that if the opposite sides are equal, then those angles are equal. So if this is 7 and this one's 7, then regardless of what these are labeled as down here, we know that those angles are equal. 4.11 says the flip side of that one. If the angles are equal, then we know that the sides are equal. So they tell us if this is a 40-degree angle and this is a 40-degree angle, then we know that both of these sides are going to have the same measure. This is stuff that you can apply, knowing that an equilateral triangle can also be categorized as an isosceles triangle. Then when we get down here to the equilateral one, Theorem 4.3 says that any equilateral triangle, meaning all three of the sides are exactly the same length, it also has to be equiangular. Now if we look back at what we were just talking about with the isosceles, where these two angles were the same and it made these two sides the same, on the equilateral you can look at it like an isosceles where these two angles are the same, so these two sides are the same. But then an isosceles from here as well, where these two angles are the same, so these two sides are the same. 4.4 states kind of an obvious thing mathematically. All the angles are 60. If this is going to add up to 180 degrees, and all three of them are going to be the same, we take 180, we divide it by 3, we come up with 60. A couple of things that you need to remember when you're working through this is CP/CTC. Any proofs that you do where they're talking about you prove the triangle is congruent and they're asking about a specific angle. If you prove that the triangles are congruent, then you can go back and say that the angles are congruent across the triangles because CP/CTC. Corresponding parts of congruent triangles are congruent. They mentioned it before as polygons, and I believe I put it in the lesson as both polygons and triangles. But since we're talking specifically about triangles, it's going to be CP/CTC. Also, don't forget the Pythagorean theorem. When we start dealing with isosceles, we could very well have a 45, 45, 90 right triangle, meaning that we know both of these are going to be the same, and this one's actually going to come up to the same thing as the other lines here times the square root of 2. If you recall some of the work that we've done already dealing with the radicals. On this, just be very careful. The equilateral stuff is easier to figure out, so they probably won't ask as many questions about that. I would expect more over the isosceles triangle.